welcome back. Nice weekend, recoup a little bit. How are we doing with module 1 so far? Feeling comfortable with Python yet? Maybe halfway. A loose acquaintance, maybe not a best friend. Acquaintance. And then for now, at least schedule-wise, we're working on project. Anything coming up with project work? Nothing? No, that can't be right. It's got to be something. All right, I'll check in, see where we're at, and then we'll come back, see what we need to take a look at. Oh, okay. Yeah. Go for it. Okay. Are you trying to solve the numericals or? Oh, that one. That one, I mean, because it's a function. And as long as you know the numerical and that one, you can see values that are this is team right. Okay. It's smaller. Okay. Yeah, and so we were just talking about if there's no difference between boilers and added function, which is what should and you can use inverted equation solve. Or you can use you can put as many into those and make it do. I think it's like I mean, you can show. Well, it looks like you're the main function, and you show that's the.
Wow, that's even know that.
All right, two things came up, and I'll talk about those before I get to the other half of the class. First was, get rid of that. So on Friday, I made this kfunc function. I plugged it into Copilot and said, hey, write documentation for me. And the documentation, at least it looks nice, so that's good. The one thing that was kind of missing was like, it didn't have units in any of this. And so I like to go through and at least put unit, especially for engineering stuff. Like that's the most important thing we have to deal with. Here, time interval, default 45 minutes. And then it tells you string for derivative, but anyway. Oh, I have an error. Oh, okay. This is not what anyone asked about, but this is a good error to kind of look at. Indentation errors. What happened here? Why am I getting an indentation error? Has this happened to you yet? You copy code in, and then all of a sudden you get an indent error? It has? Or no, it hasn't. Has anyone had this happen yet? Indent errors? You have had it? How did you fix it?
I went back and I made sure that everything was like in line correctly, and I kind of just played around with it until it stopped yelling at me.
Okay, yeah. So just guess and check of like, all right, stop yelling at me, like stop being so angry. So here, oh, yeah.
It's giving me an error because it's trying to like work based on like the previous non-indented line. It's kind of giving me an error off that.
That is where, so it's pointing at this line, and it's telling me that because of this, so the indent here doesn't match the indent on this DT line, which is weird because they look like they're lined up. At least to me. I don't know. I can't pixel. I think within 1 pixel, they're the same spot. This is, have you heard coders argue about tabs versus spaces? Some people have very strong opinions whether you should use an actual tab or spaces that are the same size as a tab. They're not the same according to Python. Tabs are not spaces, even though a tab is 4 spaces or sometimes 2 spaces, but it's not the same. So what I'm going to do, oh, and look, that one's not matched up either, right? So let's get rid of that. Let's see if that one fixes it first. That fixed it. All right, so that was my problem. I thought it was a tab spaces thing, but it was because those 3 quotes at the top were not correctly tabbed. All right, so that works. So it looks like we're good. So sometimes, one way that you can check, like, is it a tab or a space, is like go to that line and one at a time move your cursor like that. If it skips if it skips 4 spaces at a time, then that tab is not the same. But anyway, that's how you fix it, is go back and first make sure everything's aligned. If it's all aligned and you're still getting an error, then highlight everything before the error happens, and then I'll hold Shift and Tab to tab it over, and then Tab to put it back and now it's all the same spacing. This one's a weird, like Python in particular really cares about spacing because for loops don't have end for loops, if statements, def state, like all our function statements, they don't have n, like an end value. So there's nothing to stop them other than the spacing. But that's how you fix it. It's like highlight everything that might be a problem, untab it, and then tab it back over to where it should be. And then it works. Okay, so then the next thing that comes up is, let me restart. So, we run our code, everything works. Oh, cool. Didn't have a k defined. Everything worked, and I ran my function that returned k, so then let me print k. But then it tells me k is not defined when I try to print it. Even though I ran it twice. I tried to return k twice, but it's still not defined. Bless you. So what's happening there? Why isn't k defined even though I ran my function that returns k? The silence is either because it's too obvious, and it's like, man, that's a dumb mistake, Professor Cooper, or like, gee, I don't know. Where are we at? Is it the gee, I don't know, like thumbs down? Or it's too obvious, thumbs up. Yeah.
Is k only defined in the loop?
So k was defined as my function. So there's like a k func, and I say k is the derivative over this difference, and then I return it. And then I ran the function. But I don't have, but k is still not defined. Not sure. Yeah, so the fact that I called this k is irrelevant. It's a dummy variable. It gets thrown out as soon as the function runs. So the fact, like, whether I run this 100 times or once, it's printing whatever k is, but it's not actually saving a variable called k. It's just saying like, okay, you wanted me to calculate k, I calculated it, do whatever you want with it, I'm gone, and it disappears. So if I want to actually print the value of k, I would have to say k is that function, and now it'll assign an actual variable that I can access again. It stores it in my computer memory, or here, in this case, our server up in the cloud. So now that error should go away. Now I get the the backward method, k. Anyway. Cool. Anything else coming up so far? Another kind of side question was, like, if I have a function, how do I solve it? Like, if I want if I want t of t to be 98.6, how do I solve for time, that value of time? And for that, like, you can just manually you can always use math. Like computers are just doing math for you, so you can always do the math and then use the computer as a calculator. But let's say I don't want to do math, at least. Like I don't want to do a lot of math. I just want to do minimal amount of math and let computer do all the algebra for me. One option is fsolve. Fsolve is a function solver. It'll solve, if you have like multiple equations with multiple unknowns, it'll solve for all of those. Here we have one equation with one unknown. We know we want the equation to be 98.6. So what is time to get to that point? And again, this is the magic of Python. It's why it's so powerful, is you import what you need done and then it does it for you. Like that's, if we were doing like C or Java, then, oh, thanks Crosco, you're right. Yeah, there's no global. Yeah, that's another option. We could have said like K is global. That one, global variables, especially for like numerical methods, are not like best practice. They work, but sometimes it's sort of a hacked solution. We're never even going to touch on global variables in this class because we're not dealing with like object-oriented programming and building like libraries, so we're just not going to worry about it. But global variable would definitely work. Okay, so let's see. What does fsolve do? You need a function, you need an initial guess, x0, and that's the two main inputs that we need. So let's see what the function is supposed to be. It takes one argument, same length, and then some estimate. So let's scroll down. Like in this case, it's looking for x times cosine of y and y times x minus y minus 5, like something. So two values, and then it'll output a result. So it's giving us like an example of two equations with two unknowns. And what we can see is that this system of equations, it's looking for when x0 times x1 cosine is 4. So we had to subtract 4 from our equation because fsolver is only finding roots of the equation. Like it's always looking for 0. It can't find the value of 4, but it can find 0. So we can do the same thing on our equation, right? So I'll say like my func is a lambda, if I could spell. And I'm kind of manually typing it would have looked nicer if I like defined TA and T0 and all that, but I'm just manually typing stuff in just to show how this stuff works. So let's see. My func of 0 does not give me, oh wait, it gives me 98.6 minus 85, 13.5. At least that's what I think it's giving me. So at time 0, my function gives me 13.6 degrees. I'm 13.6 wrong. That's how wrong I am when I guessed 98.6 happens at time 0. That's kind of what this function's telling me. Versus if I say negative 0.3, it tells me I'm off by 10.7 degrees. So now instead of guessing and checking, I can say fsolve of my func, give it an initial guess of really anything, like 0. And then it tells me negative 1.17 is how many hours ago we had found it. And we can double check, make sure that it actually equals. And I get 0.0002, which is pretty darn close to 98.6. But fsolve, it's really like helpful, and we'll get into kind of how this works, like what's happening in the background in module 3. But for now, it's kind of a helpful like solving tool if you're trying to solve like algebraic, even if they're nonlinear. Like this is not. This one you can invert it, right? Like it's not too hard. But even stuff like sines, cosines, and other like weird functions, fsolve will get you to an answer pretty quickly. Anyway, that was the other thing that came up. It's like, how do I solve stuff? Because it should be easy, right? Like we're using a computer. Doesn't it know how to do things like this? Yes, it does. We just have to know how to massage the problem into computer language for us. Yeah.
What does it mean when you wrote lambda t and then
Oh, what is this lambda?
yeah.
Like lambda t? This is the same thing. So instead I could have written define my func of t, return that statement. So lambda is called an anonymous function because you can create a function in line. You can even create functions like inside of other functions, so like change how the inputs are plugged in. So it's exactly the same, whether you use DEF or you use lambda. Yeah, thanks for asking. Yeah. My K was 0.44. Yeah. It's a good clarifying question. Yeah. In terms of the numbers you get, yes, it will matter. Like 0.3 is not going to give you the same time as 0.4. Are you asking like in the grand scheme of life, will it matter? In the grand scheme of life, no one will remember if you chose 0.3 or 0.4. You might, maybe one day you'll be like, oh man, I chose 0.3 and it changed the whole course of history. Now we have President Trump for a third term. But no, in terms of like the assign, it's not like, haha, gotcha, that should have been 0.4. There's no like trick here. It's just, you choose one, make an informed choice of like, look, I'm using forward, and that's just what you got. Kind of standard engineering practices. You make the best estimate that you can with the tools you have, and then just report what you were doing. Some people it bothers them that it is different. it sounds like it might bother you, like you're staying awake at night. You can average them together, and then there's no question of like, look, I did forward, I did backward, average them. There's no possible way to change from there because all the work has been done. Like I've done all the calculations I can to make it more accurate.
With Outlook? No, it's a losing battle.
Yeah.
It's always.
Okay.
Now,
It doesn't take up 2 minutes.
no, it doesn't like units. It's an email system. What is the difference? So when we said like this, our derivative is dt, like a delta temperature over delta time. We made an approximation that slope is a derivative. But if we say that it's a forward difference method, that would mean that the slope is true at time 0. Backwards, the slope is true at 25 minutes. Both of them are equally long. They introduce a little bit of error because of truncation error, but it's not that great. Oh, okay. Yeah. Exponential. Starts somewhere, drops, slope changes. Nobody's having problems with like Euler integration. That's like easy now. We haven't gotten to it.
It's in there. It's in there.
Okay. Yeah.
Just gonna work
You're
on it.
just sort of trying to like realize it. Yeah. Bring it into reality. Oh, there's in the function that I had made, I created a new variable called derivative. Oh, it looks like you're using that one. Yeah. You just have to define it as like one of the inputs. Gotcha. Yeah. Yeah, like if you do another comma, there's that like derivative. Gotcha. Forward. Yeah. Now it has a decal.
I can use the same Euler equation for this one, right?
I think the previous one. Are you looking for like an exponential function?
Is adding more time for this part? And didn't we do that in this one?
Yeah, you did.
Okay.
In that population problem.
Oh, this is the one that I couldn't download. For some reason, it won't let me download the data.
What?
I didn't ask about this. I need this.
What happens if you're on that?
I can't find it. I don't know. I put a note in it too because I want to see it.
Okay.
Well, there it is. But this is the one that would be similar.
Yeah.
Okay. So then I can do that. And I did this too, but this doesn't have the it's just weird because like I don't know. Yeah. Can I find it somewhere else?
Here.
So then I can download, okay. Oh, there we go. Okay, awesome. Okay, I'll work on this now that I come back.
Yeah, I don't know why.
Yeah.
It just disappeared.
But, okay, thank you.
How's it going? Pretty good. Yeah? Sorry, what? Okay.
All right, nobody had questions on this, but I'm wondering how you're doing this. For Euler integration, what does Euler integration look like for this problem? Like, how do we set it up? Are you too busy doing it or not sure where to even start? Here, let's pull up homework and see what we've done last time for Euler integration. And get rid of this one. All right, so this was kind of the steps that we took in the homework for setting up Euler integration. Define whatever constants I need. Define my time step, how big each Euler step is going to be. Then once the time step is defined, time is an independent variable. Like, you never need to solve for time with integration methods, at least. That is your independent variable. Everything depends on time. Now I say P has to be the same as T, so it's the same shape, same size. And my first population is already known. I have an initial condition that population is 1.6 billion. Then I loop through every other population and solve for how much the population grew and add it to that initial population. So step by step, kind of Euler steps, integrating that way. What do I do here? What's the first step? I won't say step, but what's the step in the process? Not so much. there's also the first Euler step, which we do need to figure out. I can set up time, right? Same thing, it's independent. I don't need to solve for time. I can just say, this is it. Go from 0 to 3 hours, like 11 a.m. to 1 p.m. Figure out what that looks like. Let's do 11 steps. Oh, 31, that sounds good. If I do 31 steps, everything is 45 minutes from 0 to 3. Does that sound right? Oh wait, I just want to say same size as T. What's my first temperature? Temperature at time 0. 85. Then I'll start at 1, so T1, then T2, then T3, and figure out what that new temperature is based on 85 plus the change. So T of I, so I starts at 1, is T of I minus 1 plus what? What do I add to it? What's the change in temperature over 45 minutes? Yeah. 5 degrees.
So that's gonna get 85, right?
Is it always 5 degrees?
No, just for the beginning.
For the beginning? Oh, yeah, because it was, it went from 85 to 5. So it should be about 5. Yeah, should be. But where did that come from? How did we figure that one out? Yeah.
You use the repeated notes to find at the top, but just do it like T capital T equals maybe K times T minus TA times dt.
Yeah, so I'm taking exactly what that derivative is and plug it directly into that Euler integration, which is how we solved for that 5 degrees to begin with. That dt was 5 degrees, and we're assuming that it's, and then we said like it has to be equal to this value of K times T minus TA. So really I'll say subtract K times T bracket I minus 1 minus, and again, normally I would set up all the variables, but I'm just plugging in that 65. Well, let's see what happened. It would help to have matplotlib defined, but I had reset everything. Let's do this. Why does it say dt is 7.75? But then here, the first dt is not 0.75, right? What am I doing wrong? Oh my god. Yeah. Yeah, I should multiply by dt. So the derivative times that dt, but also I should define what dt is. That would help, right? Duh. I'm like, yeah, point, and like, why is 0.75? But anyway, 0.1, so it's 0.1 hours. Oh man, Mondays, am I right? Yeah, it helps to actually define the time step that is your real time step, not just like make it up. But even when you've been doing this for decades, you still make those kind of mistakes. Now, this looks a little better. This looks like more what I was expecting. And so to explain what was happening there, like why it's doing this, if there's no dt defined, then dt is 1. Because I'm multiplying, because I have to say like change in temperature times time step. But if I don't do that, the assumption is that it's 1, so it's always a 1 hour step, even though I'm plugging it in over a 3 hour time period. So it's increasing the effect of each derivative, which is not what we want. We want more something like this. It's decreasing, but kind of slowly. Slope is changing. There we go, looking a little better. What if I want to compare lots of time steps? Like here I did 0.1, what if I also want to look at like 0.5 or 0.7 or however many steps I want to look at? What would I do there? Yeah. Yeah, so we could do like different plots to, or we could put them all on one plot, or yeah, but somehow if you can do it once, you can do it as many times as you need to, because you can take everything that you just did, bump it over, like tab it over, and now you can turn it into a for loop. So let's take these 3 cells. I'm gonna turn it blue, hold shift, merge, so shift M is merge. I'm gonna take all this stuff, tab it over, and now what I'm doing is, instead of just looking at one thing at a time, I'm going to say what happens if I have like 11, 21, 31, 51, 101. Just plot every one of those results. Default is it's all going to be on one plot, and they'll all be different colors. So really I should label them, but let's just see what it looks like, and then we'll decide, do we want to keep it or kind of modify. Kind of a mess, so maybe do some modifying to start. So maybe we don't need like all this stuff in the middle. Maybe even start a little lower, like 5 steps or something, or maybe. We just have 2 minutes left. Yeah.
You want to turn off the marker, so that way you could like, because the green is like pretty much all markers.
Yeah. So I like markers for these discrete integration steps because it tells me like it's actual data points rather than a continuous function. What we can do is look at everything, like we could start at 0, go to the end, but only look at every like fifth value or something. Oh, we should do it for time too. Like if it's too crowded, I can skip. I don't have to display everything. And there, really we could do, really what I would do is say like, if len of t is more than 10, else yeah, now we kind of see like the green markers are smaller time steps, but I'm not displaying every single green marker. But that's a way for visualizing, it would help. And a little trick. This indexing, the way it works is you can give the start number, the start index, the stop, then the start, then the stop, and then the step size. So start, stop, step. Okay, so just like let it wash over you. Does this plot make sense? Is it showing something that we actually want to see, or is it just the ravings of a lunatic in this awkward lecture hall? You never know. Yeah. Yeah, show like the actual function, right? To see, are we converging to the actual line that we're supposed to, that exponential decay? Yep. And sorry, I'm not trying to keep you. We are like we're at time. I'm happy to answer questions. I'm happy to talk Python as much as you want, but that is our time.